time? Do you remember? And it's specifically for story problems.
You read the first part.
Yeah, we should actually go right here. Okay. What amount of time is needed in hours to double? And that's all the word that we really care. Needed for the number of green algae in the beaker to double. Okay. So when t is equal to 0, okay, this equation becomes 10,000 times 2, 0 divided by 2. What is 0 divided by 2?
0.
That's right. And 2 to the 0 power is
1.
1. Okay. So this becomes just 10,000 because this part is 10,000. So the number in front here, and this is important for your learning, this is the initial amount. Okay. Now, have you heard of the BD approach when it comes to testing answers?
No, I had not.
Okay, so let's try B. Let's just try letter B here.
Plug it in.
And plug it in. Now, the problem with letter B is we don't have a calculator on this one, so we're gonna have an issue with that. So let's actually do it differently. Let's do, oh, no, this one actually won't work that well for it. Let's try letter C. Okay, so we're gonna put 2 into this equation for T. Now, I don't normally like guessing answers, but we'll talk about why that might be a good strategy here. So 2 divided by 2, what is 2 divided by 2?
1.
1. 2 to the 1 power is
2.
2. 10,000 times 2 is
20,000.
20,000. Is that what we want? Is that doubled?
Yes.
Yes. Now, I'm a good guesser because I know this stuff. You may not be, but when you guess something, you should guess something that is nice. And nice means that you can do it by hand in this case. 2 divided by 2 works out really nicely. 1 divided by 2, you might say, well, hey, Matthew, that's 0.5. You're right, but it's an exponent. Exponents need to be integers to be workable for us.
Right.
All right. So let's take a look at another question here. Some of these are calculator, and I don't want to get right into that. Okay, so let's do this problem here. We're going to do it without the answer space first. It's kind of the same setup. And one of the benefits of doing this and taking the test multiple times is you start not getting overwhelmed by the format. You know, there's a lot of information here, but we're going to write to the question. Which of the following models the number of liters of the fluid in the tank after m minutes? So that's not particularly helpful. So we are going to go back and start here. The function a of t models the number of liters of a fluid in a tank after t hours. So the way this is written is if t equals 1 hours, it's 50 times 2 to the power of 1. Okay, but they want to do it in minutes. How many minutes are in an hour?
60.
60. So we know that 60 will be part of the answer in some way. Okay, so now I'm going to actually grab the answer space. And you'll see why that's important, because this does help you to eliminate some answers. Certainly, it's a good test taking strategy. So you know that minutes has 60 in it. Which answer does not have a 60 in it?
D.
D. So we know that's gone. Okay. Now let's go back to my original question, which was if t is 1, okay, what does this become? What is 50 times 2 to the power of 1? And order of operations says to do this part first. So 2 to the power of 1 is 2. 50 times 2 is 100. And you just told me that 1 hour equals 60 minutes. Okay. So one of these answers down here will give you 2 to the power of 1. And you can literally substitute 60 into each one until you find the one that works. So if that's not clear, what is 60 divided by 60?
1.
So that one's looking pretty good. What about 60 times 60? Is that 1?
No.
No, so that one's out. What about 60 divided by 60?
Is 1.
It's 1. So it could be A or C. We don't want to guess. So there is a strategy, which is you don't ever try 0 or 1. No, not it could be A, it could be A. 0, 1 is, so let's try 2. So in the future, we're not going to try 1. We're going to try 2, 3, 4. We'll try something away from 0 or 1. It looks like a good idea. Oh, try 1. Sometimes issues like this happen. So 2 hours makes this 2 to the power of 2. 2 to the power of 2 is 4. 50 times 4 is 400.
No.
2,
50 times 4.
I'm sorry, 200. Yes, thank you. Thank you for 2 hours is how many minutes?
That's 120.
120 minutes. So between A and C, which one, when you put in 120, sorry, my screen's freezing up here. When you put 120 now in for M, which one gets you to power of 2?
A.
A. All right, let's see here. All right, let me go. I'm gonna look for some different questions. I thought these were different type of exponent problems, but I'm not seeing them. So let's go to, nope. Okay, yeah, I guess these are, sorry, I don't want those. All right, so we're gonna we'll actually look at some more of these for the moment. I'm not gonna snip in the answers quite yet. We'll just talk about this question. I won't ask you to do a ton of reading, but I'd like you to read this one out loud for me, please.
The whole thing?
Yes,
From the
please. Yes, let's read it from the beginning.
A radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is 100 or 325 grams, which of the following functions F models the remaining amount of the substance in grams T years later?
Got it. Thank you for doing that. So there's a lot here, and some of it is not important. The numbers are generally important. Do you ever employ any strategies like circling numbers or underlining? Do you do anything like that when you take tests?
Yeah, sometimes.
Okay, it's a good strategy here. So there's this formula called PAT, P-A to the T. Okay, we kind of already looked at this. P is the initial amount. Are we given the initial amount?
No.
Yes. Go ahead and
Yeah,
read the second sentence until you tell me what the initial amount is.
right. 325 grams.
325 grams. Okay, so that means our equation is 325 a to the power of t. Now I'm going to circle. I'm going to bring in the answer space, and this is how you should work through the problems. Is you shouldn't you want to look at the answers, but you don't want to use them to guide your thinking. But in this case, we can exclude now C and D. Do you see why we can exclude them?
325.
That's right. That's right. And I mean, if you were just guessing, 1 out of 2 is better than 1 out of 4.
Yeah.
So like that, that's why I said sometimes your grade just improves because you become better acclimated at how to guess, how to, get the answer that you think is right here. So is this a growth or decay model?
Decay.
It's a decaying model. Okay. Now these right here, these are actually both decay models. And the reason I know that, and this would have been covered in maybe in your algebra 2 class, it's because the number in parentheses is between 0 and 1.
Yeah.
That's why it's a decay. All right. Now, unfortunately, this is like a pure definition. So the rate at which it decays is 1 minus the rate that's given. So for a decay model, it looks like this. For a growth model, it is 1 plus the rate. Okay, and the rate, what is the rate in this problem?
13.
13%. And the reason I say it that way is percents are what adults use, but in textbooks and in math classrooms, we don't use percents, we use decimals. What is the decimal equivalent to 13%?
0.13.
0.13. So in our problem, we're going to do 1 minus 0.13, which is 0.87. Okay, so the correct answer is A, but notice that B kind of looks correct because it's got the 0.13 in there.
Sorry, I was taking notes. What did you say?
I said, what I said is that A is the correct answer, but do you see how 0.13 is in the answer for letter B? And it's very easy for you to say, oh, it must be letter B. Sometimes you must know the decay and growth formulas.
Okay.
And they're awkward. I mean, they're not intuitive, unfortunately. Intuitive would be 0.13, but that's not the case.
It'd be pretty. Those B.
Yeah. Okay, so I'm going to give you the same question, but I'm going to change the numbers. I'm going to ask you to write the equation. Okay, so we're going to change this to 23% and 425 grams. And I want you to write the equation. Basically, I'm just asking you to tell me the values of P and A.
All right. Let's do 20. 77. I couldn't remember if I'm supposed to put a negative. I'm guessing not.
Let's go back and look. So let's go back and look at the previous problem here. You subtract the rate from 1.
All right. Yeah, now I'm good then. I got the answer.
Okay, what is your final answer?
25 parenthesis 0.77 parenthesis to the power T.
Perfect. All right.
Or
Excellent.
4. I didn't see that it was a 4. I thought it was
That's
1.
all right. Yeah. Okay. All right. Excellent. Okay. Let me scroll through here. Okay. Yeah. Let's look at this next one here. All right. It says the equation above can be used to model the population in thousands of a certain city 2 years after 2000. So notice that if you read it from the beginning, sometimes you don't have to. Like it really is better. Like if you go right to what is the value of n, maybe you don't know anything, but then you can go back to the previous sentence and then go back to the first sentence. But you'll find there's a lot of extra information. You'll also find sometimes you got to read it through twice. But the Model T is in years and n is in months. And what's the conversion between months and years?
12.
12. So there might be something in there with 12. We don't know. Maybe C is the answer, but you can sort of like from the previous questions, you say, well, maybe that's going to work. 0.5%. You see how this number given is 0.5%? As a
Yes.
decimal, you have to move it left twice. And that's why it becomes 0.005. And remember how I talked about a growth? A growth is 1 plus your rate. 1 plus 0.005. That's why this is the number that's in parentheses there, because it's a growth model.
Right.
Not all populations grow. Actually, the United States is in a decline right now, interestingly. What does the 215 represent? Do you remember?
It's the initial amount.
Is the initial amount perfect? So let's do this. Okay, so the model increases by 0.5% every n months. So 1 year is 12 months. So if we put t equals 1 into this model, okay, it's actually going to be going up. Well, actually, this is kind of odd. So I don't want to do this. The model increases when the exponent is 1. When does t divided by 3 equal 1?
When T equals 1? I have no idea.
Well, so I'm asking you to solve this equation. So you can cross multiply. T times 1 equals 1 times 3, or T equals 3.
Okay, yeah.
So that the 3, when T equals 3, in 3 years, okay, this thing, the exponent is 1, and that's when it goes up by 0.5%. So the like it goes up by the growth rate when the exponent is an integer.
Okay.
So 3 years, but it's not 3. Why isn't it 3? It's because it's in months. So whenever you get A as your answer, you should really check yourself. So, well, is it really A? No, we want to convert this to months, which is 36.
That'd be D.
Yes. It'd be D. Good. All right. So there's some other questions here that have to do with graphing. Let's do a quick review on graphing before then. All right, so the typical graph of an exponential function would be like 2 to the x, and 2 to the x looks like this. It goes up and to the right. Do you remember what putting a negative in front does to a graph?
It puts it downwards, right? Like
Yeah, it just goes down like this. Okay. But where it gets a little bit more complicated is, well, what is 2 to the minus x? What does that look like? And don't guess here. I'll just show you.
Okay.
It ends up being a decay graph.
Okay.
And so if you put a negative in front, it flips it again like that. Yeah. So if you were going to commit something to memory, it would be these 4 graphs, or at a minimum be able to like move between them. Now, this is not enough to like get questions right, but it's a starting point. And sometimes that's all you need. You just need a place to start to be able to answer the questions. Okay, so let me pull up a question here. This one's not too difficult to start out. If you had a calculator, which you would not have one on this question, so unfortunately you can't say, oh, just graph it. You actually do need to know how to do this by hand. So this graph goes up and to the right. Okay, and all of these graphs go up and to the right. The only thing that's different is the number off to the side here. All right. So I didn't cover this, but the parent graph looks like this. And it goes through 0, 1. This graph goes through 0, -1. So how much up or down is it shifted from this original?
It's gone up 1.
I think it's no. So the original is up here at 0, 1. This one is actually down below the origin.
Oh, that's what you mean. Okay. Yeah. So it's gone down -1 or gone up -1.
It's gone down 2 is what I'm trying to say. Like the original, let me maybe okay, so maybe to do it this way. The original graph looks like this, and I'm trying to get you to see that it.
Oh, it's the same thing down 2.
Yes, it's down
Okay.
2. So what I'm asking you to think about in terms of graphs on the right here, which of these are down 2? If you
D.
recall, D. But you got to know the parent function, because it takes too long to graph each of these. All right. Let's see here. Sorry, I've got a big problem set here. I'm just trying to find some that we can sort of incrementally go through, not just. So this is a good one for us to look at next. Let me grab this. All right. So notice the original graph up here goes through 2, and it says the graph of a function is shown. They're telling you like, hey, this is given up here. And they're saying, what is the graph of f of x minus 2? From our previous problem, what do we know that minus 2? What does that minus 2 do?
Just moves the graph down 2.
Moves it down 2. So which of those moves down 2? And A looks like it moves up. So we would
C.
say C. All right. All right, give me just a moment here. I'm just gonna take a 1 minute. Hey, Elijah, are you back? Let me know when you're back. You may have muted yourself.
Hello?
Hey, can you hear me okay?
Yep.
Excellent. All right, I want to switch topics because I'm sort of want my goal is to cover 2 topics with you per lesson, and I think we can do that if we are really on point here, and I think you've done a great job thus far to do this. So it's a lot to do math, especially when you're not in school. But I've got a new question for us. We're gonna transition to polynomials. Let me actually stop. All right, in the equation above, what is the value of x? So this is one of those where you would definitely not want to try the answers, okay? Because even if let's just say you tried 1 and you tried 3 and they were both wrong, this is really bad because fractions are hard to check. Would you agree with that?
Yeah.
Okay, so this is really all about combining like terms. So on the left side here, how many x's are there in total?
There'd be 6 X's there.
There are 6 x's minus
Can,
5. Sorry, go ahead.
can you not hear me?
No, I can. I can hear
Okay.
you. Yeah. And then on the right, it's 7 plus 2x. All right. So how do you solve this equation? Do you remember from one of your classes?
Yeah.
All right. Why don't you try solving it for me?
You want me to tell you or you want me to just write it down and tell you the answer?
You can write it down and tell me the answer.
Okay. 4. Okay, x equals 3.
All right. So that is there. Perfect. So we want lots of questions like that on your test. But whether you get them or not, we don't know. All right. Okay. So the next question is about adding polynomials. Okay. And I'm going to just paste the question before giving you the answers. You'll notice like sometimes it's better to even cover, it's better to cover up the answers. And in our case, I'm not showing them to you. And this is a test taking strategy because you sometimes want to use the answers, but sometimes when you know what to do, just do it and then compare your work to them. So in this problem, you're just adding up these 2 polynomials. You're just combining like terms. You're combining the 2x with the 2x, the 6 with the 1. Okay. You cannot combine the x squared with anything because there's no other x squareds. Okay. So will you combine those and give me a final expression that would go in parentheses or in this box here?
X squared plus 4x plus 7.
All right. Now I was actually talking to a guy yesterday about some of the problems. And believe it or not, like this sometimes happens on exams where you do the work perfect, just like you did, but do you actually mark down the correct answer? What is the correct answer to this one? It's the same question.
D.
D. Good. All right. Okay, so a slightly more complicated one. I want you to try this on your own, please. And just let me know your final answer, A, B, C, or D, please.
Okay. What did I do?
So did you do the problem and then try to find your answer and they didn't match, or did you, what did you do to try to solve this?
I got the answer, but I did something in my Zoom, so I don't know what I did.
Okay,
Oh,
well,
there we go.
take 30 seconds to get it back.
Okay, I got my answer though.
Okay,
I probably did something wrong, but I got A.
okay, A is not correct. Let's try again. So one of the techniques that I like to do is using like underlines. Why are those like terms? Why can you combine? Sorry, go ahead.
A square. So you
Because
can
it's an
combine
X and yes. So how many of those are there?
5x.
Yeah, and that doesn't help you because they all have it in there. So you actually, well, I'll get to that later. The next one is, and you can do it like this, you can circle it. Now circle it with the operator. And that's a little thing like you have to circle the plus and the minus because plus 3x minus 8x is
-5? Or is it
minus
plus?
5x, minus 5x. Okay.
Okay.
So we're in good shape. It's either A or C. What is -4? And this is the you can box things, you can do other things. So it actually is A. I wanted to hear how you work this out. I didn't want you to just say A because you saw it first, but that's good. Did you feel comfortable doing that question?
Yeah, I had to redo it a couple of times just to make sure it was A though.
Okay. All right. All right, here's a good question. All right, which of the following is equivalent to? All right, so again, what I would do is work it out and then compare my answer. And I'll remind you when you're distributing, you distribute to both terms.
Yep. I
Okay,
remember that.
so give this one a try on your own, please. And let me know when you got your final answer.
Okay. Okay, I think here, let me
Did you get letter A again?
yeah, I did.
A is correct. A is correct. All right. All right, let me have you do this one on your own. I'm gonna have you do two more. And if you get them both right, we'll just move on to another topic. We might get to 3 topics today.
Let's go.
Doing great. All right, I'll give you 60 seconds, 1 minute here to work this out.
Plus 13x. Plus 2. Okay, I got C.
How confident are you? I'm just asking because you did this on your own. Like, do you feel like you did it right? Like, what? Tell
I
me.
feel like
So one of the things like I noticed here, and this is what I wanted to ask you. Do you notice that this column is different? And then like even like this one is different. And then even this third one is different, but the first one is not. Well, I guess they are. I guess I didn't catch that. Sometimes it's a good idea to actually look at the answers and figure out like what's the same and what's different. But the way I would do it is I would still say, okay, 12x to the fourth, 6x to the fourth, that's 18x to the fourth. That means it's C or D. Minus 5x, and then I would go with the 7x. That gets me to 2x. And I would say, oh, there's my answer, letter C. I think that's what she said. Good. All right. Does this seem difficult to you?
No. No, it
Good.
doesn't.
Good. It shouldn't be. You're doing great. Okay, one more here, and then we're going to move on to a new topic.
So basically what you're saying is like, as I'm working through the problem, look at the answers and compare.
It depends on the problem. I was trying to think of a basketball analogy, but I can't think of a good one. It's like sometimes you want to look at the answers, but sometimes you don't. And the more problems you do, the better feel you get. When it says which of the following, but you have to work it out, that's when you would want to ignore the answers because you really want to work it out and then compare. But
Okay.
if we go back to an earlier problem where it's like, which of the following, and it gives you four answers, that, like sometimes the questions like make you look at the answer space is what I'm saying. But
Okay.
sometimes it's better to work it out and then compare to that.
Okay. All right. You want me to do this?
Yes, please.
All right. I got C.
Letter C here. Okay, so when you multiply in to each of these, you get 2x cubed plus 2x. And then this other one over here becomes plus 2x squared minus 2x. So the 2x's cancel, and yes, it's letter C. Excellent. Excellent. All right. So I'm seeing a pattern here of like when I give you sort of more of an algebra problem or more of a like the equation is given, you're doing pretty well. We're probably going to have to transfer to some more story problems because that's probably where you're struggling the most to be able to answer and do well in this. So let's look at one here. We're going to switch to perimeter and area. This would be part of geometry. So it says the width of a rectangular dance floor is W feet. All right. So here is a rectangle. Which is the width? Is it the vertical or the horizontal?
Horizontal.
It actually doesn't matter, but that would be the preference to put it down there. The length of the floor is 6 feet longer than its width. So I've already drawn this incorrectly, but it actually doesn't matter. Like, don't redraw it. That'll save you some time. Just put it there, even though maybe it doesn't make any sense because this is shorter, it's not to scale. Does that bother you? I mean, like, because I know some students say, I got to redraw it over here. It's got to be, W and W plus 6.
Not really.
Okay, that will save you time. Now, what does the word perimeter mean to you?
The outside, the 3-point line.
Yeah, okay. Good analogy. Yeah, the 3-point line. Like in it at its core, it's actually a walk around. You're literally walking from one place to the other, and it's the same here. You're gonna traverse the outside of this rectangle. So it is a good idea to write in the other dimensions, and to find the perimeter, you're just adding these up. Okay, so will you add those up for me and tell me what the perimeter is in terms of W? It's gonna have a W in it.
4W plus 12.
4W plus 12. Perfect. All right, excellent. All right, so let's look at this next problem. It's another story problem. I'm sorry, it's just these are, you're gonna get some. We gotta do
Admit
good.
it. That's what I'm worst at.
Yeah. All right, so it says a landscaper is designing a rectangular fountain. That's weird. I've never seen a rectangular fountain. Okay, with a 4-foot wide path around it. So here's the fountain, and then the 4-foot wide path around it means that this is the path. Do you visually agree with my picture?
Kind of. Yeah. Yeah. Sure.
Okay. I mean, you've been like, think of a swimming pool and you got a path around it or something. I mean, that's what this is. It's a, okay. So actually, again, I keep making this mistake here, even though I've told you to do this. We actually need to go to the last question or the last sentence first. It says, in the design, how many feet will the perimeter of the fountain increase for each additional square foot of the path's area? And you're like, I don't know. Let's go back and read some more. The equation A equals 4P plus 64 will relate the area A to the perimeter P. So this last sentence here, because they don't give you enough information to do anything more than this, they're actually asking you to solve this equation for P.
Okay.
Okay, so we did a little bit of that. These are called literal equations the other day, 4P plus 64. The first step is to subtract 64 from both sides. So you have A minus 64 equals 4P, and then you divide by 4, right? And so 4 is divided by both, or you divide both by 4. Can you tell me what 64 divided by 4 is?
It's 10, 15. It's 16.
It's
I don't
16. It actually doesn't matter though in this problem. So try to, if you're not able to calculate something, you may find that you don't need it. Okay, and you spent, I don't know, I guess like 20 seconds trying to figure that out, and we actually don't need it in this problem here. So I'm going to rewrite the equation this way. And I'm going to write y equals mx plus b below it. What is the slope of this equation?
1/4.
1/4. Okay. When it says how many feet will the perimeter of the fountain increase for each additional square foot of the path's area, they're essentially asking for what's called the slope. Okay. And that would be how you would answer this question. But it's a good example of I really need to stick to this with you. Is we really should just go to the last sentence first and see if we can, make some sense of this. So we will do that here. Do you know what kind of calculator you're allowed to use on the ACT math?
I think just like a standard scientific.
Okay. Do you have one handy?
No, I don't have one on me.
Okay.
It's a
Try to bring it for our lessons or have one. Don't use your phone. It's bad to practice, without the right tools. If you can, I would appreciate that. Okay, so let's go right to the question. It says, what is the perimeter of Janice's fence if the area of her garden is 5,670 square feet? So we want the perimeter.
okay.
Okay, but they give you the area. They tell you that's the area. Okay, so now we go back and we'll go back and see what we need. Janice puts a fence around her rectangular garden. The garden has a length that is 9 feet less than 3 times its width. So here is the garden. Here's the width. The length, this other dimension here, is 9 feet less than 3 times its width. Could you try converting that to an equation for me, an expression actually? What about the 3 times its width? What would that be?
3 times W
3W.
minus 9.
There you go. So you can do this. It's just not ideal. I agree, and I get it. Okay. So how do you find the area? You multiply the base times
Height.
height. All right. So you have to do W times 3W minus 9 equals 5,670. On the left here, it's 3W squared minus 9W equals 5,670. Do you remember the divisibility rule for 3?
You could take 3 out of everything, I'm guessing.
No, not everything. That's bad. So you actually add up the digits here, 5 plus 6 plus 7 plus 0, and that equals 18. Since 18 is a multiple of 3, you can divide it. And I'll talk about that in another lesson because it does save you some time every so often. Okay, do you have that calculator handy?
I
Or
do not.
You do
It's
not.
in my-
Okay, that's okay. I'll do the calculations here for you. So 5,670 divided by 3 is 1890. So W squared minus 3W minus 1890 equals 0. What kind of equation is this? Do you remember from school what that is?
1 second, I'm writing it down. I have no idea.
So it's not a linear equation, right? Linear equation's a line. What does this 2 up here mean? You do know this. I'm going to try and force you to answer, see if you can get it. It's a quadratic equation.
Okay. Yeah, that makes
Right.
sense.
Parabola, U-shaped.
Yeah.
Okay. All right. Okay. All right. So I'm going to factor this for you because it's going to take too much time if I ask you to do it. Now that it's factored, this is the factored step, and we'll talk about how to do this in another skill. How do you find the values of W? Do you remember what you do with each of these factors?
You like plus and minus something.
You set them equal to 0. And the idea is that if this is 0, 0 times anything is 0. And if this one on the right is 0, 0 times anything is 0. So and then you solve them individually. So W is 45, W is minus 42.
Yeah, I remember that now.
Okay, good. Now, did the problem want the width?
It wanted the perimeter.
Perimeter. So we need the width, okay, but we don't necessarily need this value. 3 times 45 is 135, minus 9 is 127, and then you can add them up and find the perimeter for this. So this is a pretty long question. Would you agree?
Yeah, it's pretty decently long.
Yeah, and I have a question of the week that's like this, and it's a 2-page solution because it's so long. Has anyone talked to you about how to manage your time on these exams?
No. This is the first time I've ever worked like anything on the ACT.
Okay. Do you have a shot clock in your basketball games?
Yeah.
Okay, it's kind of like that, and I don't know how. Like, are you the guy that gets the ball at the end when the shot clock's running down?
Yes.
Okay, so you got to have an awareness. Like, all right, I gotta do something. The same thing applies here. Okay. How are you in general with your time management? Are you generally early, late, just on
I'm
time?
I'm always earlier than early.
Okay, so you're aware of the time, and you've shown up on time to our lessons. That's great. When you are practicing, I would set a stopwatch or 60 seconds. You want to be really aware of like what an actual minute feels like. And when you play a sport, it's different when you're practicing versus a game. So you want to like go into pressure situations. And um, I don't know exactly how what your routine is in your life, but maybe try doing a question that I put up here today with you, but do it under a stressful situation. See if you figure out how long a minute is, or do one when you roll out of bed in the morning, or I don't know, if you do a run, you go run around your house or something. Just like try to figure out mentally like what a minute is to you, because that's about how much time you have per question. And
Okay.
if you get a question like this, I mean, we probably spent 3 or 4 minutes on it. You want to skip this problem. I mean, you want to guess. I think guessing's okay, but you don't want to. Your goal here is not to get a perfect score. So if you see a problem that's going to literally take you 3, 4, 5 minutes, you don't have the time to do it. And that's what I'm trying to get you to get a sense of, because we did a problem earlier. I don't know. You did a bunch here in a row. They took less than a minute, and that's great. That gives you some extra time, but you don't want to waste it all on one problem. Okay, and they're going to cover that in that prep class that you're seeing there. You're going to go to the community college, but you need to be aware of like what a minute is, and it sounds like you already know because you're early. You're paying attention to that. All right, let's see if I can get you to do one more question for today. Can't do that one. All right, let me see if I can find. All right, let's do this one. because we hinted at it a little bit in this last problem here. All right, so it says, what are the solutions of the quadratic equation 4x squared minus 8x minus 12? Do you agree that each of these numbers are divisible by 4?
Yes.
And you can do that immediately. You can divide by 4. So that's x squared minus 2x minus 3 equals 0. This type of factoring is called a equals 1. It refers to the fact there's a 1 out in front. Do you recall from school how to do this type of factoring?
No, I do not. I don't remember.
Okay, so you're trying to find two numbers that multiply to minus 3, but add up to negative 2. So for
One-
example, go ahead. You already got it, so go ahead, tell me.
So it'd be x plus 1 minus, and then x plus 3. I have no idea. I don't remember this because
Well, I think you
this,
do, because you just told me the right answer. I mean, you maybe got a signer here, and I was going to run through that, but so this is something we'll look at next time. I've actually got a really good worksheet. I'll go through with you to get fast at this, but this is a good stopping point for us. The lessons are about 50 minutes, so please try to make some time to review the lesson notes and video.
of
And
course.
thanks for letting me help you, and I'll see you next week. We'll keep going on this stuff.
Thank you so much. Really appreciate it.
You're welcome. Have a great day.
You too. Bye bye.
Bye.